Hello everyone, you are welcome to clip 1 in part 6, which will be about the technologies. We have discussed before in the previous 5 parts the contents or the terms or the block diagrams of wireless communication. We saw the concepts of digital communication, antennas, the problems of wireless channels. So we have discussed also the modulation techniques and how to achieve high data rate and some like specifications or performance. However, from this part, we will start to talk about the technologies and also a little bit more about higher layers in telecommunication and what is the meaning of layers in telecommunication and also networking, the internet protocols, and also little bit more about some communication protocols for ad hoc networks, which is very important in sensor networks and in ad hoc networks in general. And also we will go through some technologies, like when we talk about Bluetooth, Zigbee, Wi-Fi, the cellular networks, 5G, 4G, the difference between them. So within these two parts, part 6 and part 7, we will review many different technologies. Okay, and the outlines of part 6 is we will start with a review of wireless technologies, applications, requirements, telecommunication layers, internet protocol, communication topologies, carrier sense multiple access, routing protocols, short range technologies like Bluetooth, Zigbee, ultra wideband, NFC, low energy communication, batteryless communication, and Wi-Fi technologies. So these will be the general topics of part 6. Of course, it will be as before, it will be given over several clips. What is the learning outcomes? So after watching all the recorded lectures in this part and attending the online sessions and performing the quizzes successfully, you will be aware of wireless technology and communication layers, be able to describe how the internet protocol is working, be able to explain the carrier sense multiple access with collision avoidance, which is one major communication protocol for short and medium range systems, communication systems, be able to differentiate between different small range technologies such as Bluetooth, Zigbee, near field communication, NFC, and ultra wideband, and also be able also to select the best for your own application. Be aware of multi-hubs communication and batteryless devices where the energy is very critical issue. Be aware of different available Wi-Fi standards. So we will have a lot of like information out of this part 6, but of course not in very details as we did in the previous parts. Wireless technologies. So we know that in general, when we talk about wireless communication, we can divide them into two parts, like infrastructureless networks. We call it ad hoc network, where, for example, if you have multiple like multi sensors, you distribute them in one area, and there is no gateway or there is no, for example, infrastructure. There is no base station to take care and to control how those sensors will communicate with each other, or how to communicate with certain uh, data concentrator, packet data concentrator, or the gateway, and so on. So in that case, we call it as ad hoc network. And of course, we have protocols how to manage the communication in ad hoc networks. And also we have infrastructure based networks like cellular network. For example, we have base stations, and if you have mobile phone and your friend is only 20 meters or 50 meters distance from you, and you want to call him over the mobile phone for some reason, then the communication will go through some base stations to the core network, and then this takes care of the communication between any two terminals inside the network. So we have infrastructureless networks and we have infrastructure based networks. However, in general, we can divide the communication technologies as shown in this figure on these blocks, that we have wireless connectivity. It can be divided into electromagnetic based or ultrasonic based. We know that ultrasonic also is wireless, of course, but it uses like a mechanical wave, not electromagnetic wave, and it is mainly useful for underwater communication and for some other also special applications where wireless or electromagnetic wave can be blocked effectively. And in the electromagnetic based, so it can be divided into like maybe at least those three categories: radio waves, visible light, and invisible light. Nowadays, we have like even some products working in the visible light communication. For the radio waves, which is actually our main um, interested part here, can be divided into short range, medium range, and long range. So in the short range, we call it like personal area network. And for the medium range, we call it like local area network. And for the long range, we call it like wide area network. Actually, we have even in the short range with this personal area network, we have also shorter range, which can be just few centimeters, and we call it like body area network, which is mainly used for like some application related to health. And for the personal area network, or for the private area network, as you like to call them, that it is mainly for short range, and those can be, for example, Bluetooth, Zigbee, and RFID, near field communication, ultra wideband, and maybe there are also some other like communication standards here. So those are mainly for short range. What we mean by short range, actually, there is no strict limit for the range, but plus minus is within 10 meters, 10 meters, 20 meters. So we call them as short range. Like Bluetooth, for example, we have different classes, as we will see them later, about the transmitting power. So some of the Bluetooth, when we work at the highest transmitting power, actually the distance can be up to 100 meter in the like in open area. Okay, however, that in indoor it is within like up to 30 meters. But anyhow, in general, short range we mean within like less than 30 meters in general. Okay. And for the medium range, for the local area network, like our Wi-Fi routers at home, so usually it can cover like one flat um, within maybe 100 meter, 50 meters, so it is within that range. So the medium range, actually it is up to 100 meter. Of course, even if it is 150 or 200, as I said, there is no strict range when we say that it is 100, when we say that it is local area network. So but anyhow, it is within that range. Even for the LAN, for the local area network, actually when they install some like bigger antennas or higher directive antenna or gain antenna, and direct the local area network within only one like direction, actually the distance can be up to like few kilometers in some cases. However, of course, it was not, the standard was not designed for that. And actually there are also in some countries it is not allowed, it is illegal to use like directive antenna with your LAN, because this can introduce high interference for the other devices within that loop, that the radiation pattern loop. So, but anyhow, the Wi-Fi is designed for like around 100-meter distance or 150 meters distance. So it is local area network. We have this Wi-Fi, and it can be also the standalone millimeter waves. Millimeter waves actually is it will be part of the 5G, and maybe it is not that distributed that much right now, but it is coming. That it uses millimeter waves range, so it is more than 30 gigahertz, and actually because of the high frequencies at that range, so the penetration is limited of that wave, and also the coverage behavior is quite limited. So it will be more visible application, or it is more visible application will be in the medium range, like in airports, and in, for example, one big corridor in company or something like that. uh, in the long range, in the wide area network, we can divide them into two categories here, like standalone or third party. Standalone means that it will work under your, or under the company control, fully controlled. So the company will own all equipments in this communication long range, and it is actually, we have some standards like low long range one standard, and actually with those new relatively new technologies, we have many other standards like sigfix, and there are some actually mentioned before, and they can work for long distance or long range, 5 kilometers, 10 kilometers, 15 kilometers. But of course, it is not a global communication, unless, of course, if you have gateway, and during this or within this gateway is connected to the internet. So of course, then you can receive your signal from anywhere. And we have Tetra communication system. We have private WiMAX. So WiMAX, even it is not anymore that famous, because it was many companies replace it with this LTE advanced, and also the coming 5G. However, of course, the standard is still there, and maybe some companies are interested to buy the transceivers and antennas for this WiMAX to build their own communication, like private communication network. And we have also CubeSat. CubeSat is one of the new technologies, relatively also new technologies, where companies might send like a small satellite in space, and we are still in the like beginning of this technology, and it is expected that it will have more applications in the future. It is like moderate cost to send like small satellite in orbit. And then the third party is based on like another operator. So you just like rent the service from them, and like cellular networks, which is which includes like 3G, GSM, 4G, 5G, and of course those can provide very like wide range or long range communication, and satellite networks and WiMAX general. So we have also those third party, and it depends, of course, on the costs, and also to the aim of companies, because many times it is much easier to have like modem from for mobile network, and just plug in this modem into your communication path that you want to communicate, and then with this modem over 3G or 4G, then you can get access to the network and send your messages, or for example to your, if you have meters, smart meters, and you just put your SIM card there, and you can read your SIM, the meter from anywhere in the world. So they are, it is easier to use, but many times companies they don't prefer that solution for two reasons. One reason is the cost. Of course, the cost of cellular network is not that much if you use like a few SIM cards, but when you want to distribute tens of thousands of these SIM cards, then of course the story is different. And also, the other path is the security. So for like very sensitive application, security application, they can sometimes they do prefer to have their own standalone solution. There are also some other, of course, issues related to the quality of service, as we mentioned them before, like delay in delivering packets, especially in automation application, like for example in protection or taking some control signal that you want to control some some part of in your grid or in your system. In that case, the delay can be problem. So cellular networks, it was not able to deliver messages at very small latency, like less than 1 or 2 millisecond. But now with the 5G and also the coming 6G, this will be handled and resolved. You can see here in this figure that we have several standards, and we put here the peak data rate that you can achieve, and we put here the coverage range or coverage area. So you can see different applications. So it depends on your own application, which one fitting well for your application. So for example, if you need very high big data rate, but for short distance, then maybe millimeter waves comes best. If you have also high data rate, but even for shorter distance, then there's ultra wideband. If you have a short or small or like slow data rate, but you need to cover larger distance, then you go to the LoRa one and so on. Okay, so the selection of the proper wireless network for certain application depends on the application requirement. For example, the service distance, required data rate, maximum allowed latency or delay, costs, and level of security and level of reliability. We talk about most of those in the previous parts. Telecommunication layers, actually dividing the communication into layers, it has like or it solved some problems related to flexibility and development of telecommunication in general. So it has solved the complexity of like communication networks. Actually, wireless communication networks, especially in the cellular networks, is known as one of the most complex man-made systems. So we have like of thousands of interactive control signals, commands, and the protocols working together. So looking to all this like huge complexity system as one and trying to study them as one, it can be almost impossible to do that. So it was much easier by dividing them into layers and study every layer alone. And also, actually, we can design the layers separately and having, of course, some interaction between layers. We have different layers like representation. One of the famous layers, it was developed for computer communication, is called OSI layers models. So it is Open System Interconnection, OSI, which was developed by ITU. And some of the benefits of using that layered representation of telecommunication, that to separate the various parts that form a communication system, to introduce the possibility to modify or even change an entire layer without the need to redesign the whole system, easy debugging and system verification, easy maintainability, and future extensibility or flexibility in general for telecommunication systems. So actually, you can see this is the seven-layer model, OSI. It is known as OSI seven-layer model, and we divide the communication into this form that is starting from the physical layer up to the application layer. As you can see, number one is the physical layer. Physical layer simply is the layer which is like responsible about delivering the message. For example, you have let's say phase shift keying modulator and antennas. So in that case, you're making the modulation and power amplifier, and then you have the antenna. This is physical layer. But physical layer can be fiber optic, so you can just plug in your fiber optic, your laser beam and fiber optic, and connect them to connect to the other receiver. Or it can be ultrasonic, it can be I mean the communication. It can be let's say CDMA, or it can be OFDM, whatever. So whatever was the communicate the physical layer is related to the last part where it will deliver your message. Of course, for the transmitter, it is the last part. For the receiver, will be the first part in this OSI layered model. The second model here is data link layer. So in the data link layer, actually, we take care about many tasks. For example, the error detection and correction. So once the data is received here, so after the demodulation process in this physical layer, the data link layer will check if the data was correctly received or not, and by using, for example, forward error correction, or if we use ARQ, then if there is error detected, then it can ask for retransmission and so on. But we will see later that this error detection without correction, it can be also done at like transport layer, as we will see. In the network layer, this is very important layer actually in networks, in wireless networks, because it decide the protocol how to deliver the message, and also to add the address and the routing information. So for example, if you want to send from this transmitter a message to certain receiver, so the other receiver should have some address, so the address is added here. So we add the address, for example, and the route that the message should take until it reach to that address. And of course, they add also sometimes the address of the transmitter, because if the message was not delivered correctly, how the receiver will know that who transmitted this message. So they should know also the address of the transmitter to ask for retransmission, or to respond to his to it is the messages. Okay, and then we have also the transport layer. In the transport layer, actually it is packing layer, and also it controls the flow of information, because sometimes if this network needs to for retransmission, then they should stop the flow of information and retransmit the previous message. So it has also many different applications here in the transport layer. Also, it has the capability to detect if there is error. So only detecting the error, not no, they don't try to correct the error, but they can detect the error without going into what the message means. So if there is error, then they can send, for example, negative acknowledgement to the transmitter, or they can ask for retransmission. And then we have the session layer, and in the session layer, it can make the synchronization between two applications onto the model. And we have the presentation layer. It is like source coding, similar to the source coding, because when the application layer makes some message to be transmitted, then the presentation layer can make, for example, compression or encryption, the decryption process to the message. And then we have the application layer. So the application layer is actually, for example, your Facebook. So you are open your Facebook. So Facebook is the application layer now. So you can post your message, or you can read some like post, or you can like request to see some video, or you can start some calling over the messenger and so on. So all these are the main layers. Of course, separating the communication into these layers makes the analysis easy, and also the design. For example, if you want to change the way that network layer, or if you want if there is some development or improvement in the routing process, so you don't need to look to everything here. You just come to the network layer and update it with software, for example, update or firmware update to include some features in the network layer about the routing, for example. And this makes things much easier. However, of course, to make it more efficient, then we need also to have like interaction between layers. So we have what is known as cross-layer optimization. So in all modern communication systems that we use this cross-layer optimization, that when you design the communication system, actually the physical layer also depends on the application, what you want to send. For example, if the transmitter wants to send like very high data rate, like video, for example, at 4K, and it requires certain specifications about the delay and the frame rate and so on, then the physical layer should be able to do that. And then if it is not possible, then we can go back to the presentation layer to reduce the data rate and so on. So there will be, or there should be, like cross-layer optimization to maintain like optimum operation of the telecommunication. You can find here more description about those layers, and we have also another four layered models. So the four layers model is simplified version of the seven layers model, as you can see it here, and it is mainly used for smaller devices. It is actually a good representation when we talk about Bluetooth, about Zigbee, about some IoT applications, where we have here, for example, in the application layer, we have data and application layer, where we have information, sync, source, encryption, decryption. So you can see that the first layer, it will include both the application and the presentation layer from the seven layer model. Then we have the network layer, where we have the logical addressing, packet paths, routing, and so on. We have data link layer, where we have media access control, physical addressing, errors detection and correction, and the physical layer, where we have the modulation, antennas, and for example, if we have fiber optic transmission and so on. Now we come to the internet protocol. Okay, so now we talk about the internet protocol. Just briefly, of course. So the internet protocol actually is the backbone of most modern digital communication networks nowadays. So it makes the communication very flexible and efficient, and in the same way. So the idea is that, so we use actually mainly which is known as in the network layer, it's known as the internet protocol, and in the transport layer we use this TCP, which means that transmission control protocol, and the UDP. We will come later about the difference between them. So the idea here that the application, for example, you have HTTP, HTTP or VoIP or whatever. This is the data, and then we add the header for the TCP or the UDP, user datagram, like protocol, and then we have the header for this, and then the internet IP will add the IP header for this communication, and then we have the link for the error detection and corrections, and also medium access control protocols. It is added here to the link layer, and then we have the physical layer. Okay, what is the idea of the internet protocol? The idea that every device connected to the internet, it should have its own like address. Okay, this address can be static or it can be dynamic. Dynamic address means that when this device is out of the network, then its address could be allocated to some other devices because of the limitation of the addresses, especially in Internet Protocol version 4. But in version 6, of course, we have much more. So actually, we can have static address for every device in the world. But anyhow, both of them they are now in work about both the protocols. However, that it can be, as I said, dynamic address or static address. But the idea here that every device connected to the internet, it should have its own address. Okay, when it is active in the internet. Now, if you, for example, your computer or your mobile phone, you request some information, you request some image, or you send some letter, or email or whatever. So sometimes we don't see that where we send it because we have like name, it is name, but actually behind that name we have the address. So your transmitter knows, and so your transmitter will add that IP address that you want to transmit your message there, and also it will send your own address of your device. And TCP is in the transport layer. The TCP in the transmission control protocol, it is also known as reliable control. It will check the message that it has been delivered correctly. Yes, so the operation of the TCP protocol, that when there is some message to be transmitted from the transmitter to the receiver or from the source to the destination, they will start in the beginning to establish a connection. So the TCP protocol, the transmission control protocol, that it will establish, the TCP will establish at the beginning a connection between the source to the destination. Okay, and once the connection is established, and then they start to transmit, and for every packet transmission they will wait for the acknowledgement. So if any of those packets were not delivered correctly, then it will be retransmitted again. So it is, as I said, the TCP is designed for high reliable communication. But you can see that for some application, like if we talk about voice communication, or for some delay sensitive applications like sensors, that for example in IoT, Internet of Things, where it has a message and or measured value, they should be transmitted and arrived within limited time. It is clear that TCP might not be the right selection. So in that case, we can switch to the UDP protocol, where here wherever there is message, it will be transmitted, and there is no establishment for the connection between between the source and destination before the transmission. Wherever that there is data, so they will send the data, and usually there is no, or it is not needed to have retransmission if the data packet was not delivered correctly. So this is actually a better protocol in case that you have delay sensitive application. For example, as we mentioned before about VoIP application, if you have WhatsApp communication over voice, of course, if there is few packets lost, it is not a big problem at all. For example, if you might lost like hundreds of packets, which can be like zero point 0.2 second or zero point 0.1 second, even we will not notice them, notes that there is like disconnection in the in 100 millisecond or 200 milliseconds. Actually 200 milliseconds might carry like hundreds of packets of UDP. Even if all of them lost, sometimes we don't even notice that. So if we use TCP, that we are looking for uh, over every packet that it was transmitted correctly and received correctly and making the acknowledgement, this can introduce higher delay, which is not reasonable for many different time sensitive or delay sensitive applications. So this is actually very fast like review of the TCP IP protocol, or the known as the internet protocol. As I said before, it has introduced a lot of flexibility in telecommunication. Not like circuit switching communication, where we have established like a fixed connection during the call. Now in the internet protocol, like policy, so we just put the header, the proper header, the transmitted packet knows where it should be delivered, and also the destination knows from where this packet came, and that's it. And it can take any routing like or route in the network. Of course, sometimes we have limitation to minimize the the delay, and we will talk about routing conditions later. So that's all about this TCP, IB, and UDP IB protocols. So the communication network topologies, we have like mainly three kinds of topologies for ad hoc networks. We can have like direct connection point to point, or we can have star connection point to multi-point. Actually, this is the when we have structure based network, where we have base station, for example, and then every terminal should communicate to the other terminal through some star connections, through some like backbone. And then we have mesh network, multi-point to multi-point, and this is the most like reasonable one in many ad hoc applications, where sensors can communicate to each other. For example, if sensor A wants to send message to sensor, for example, B, and this is sensor B, and the coverage range is not enough to reach directly to B, then it is possible to have it over like different routing, different routes until B. Actually, sometimes even the power of this A is enough to reach B, but we do prefer this multi-hub in order to reduce the consumed energy, as we will see later in this part later. Carrier sends multiple access, so let us discuss this in the coming clip. Thank you very much, and see you in clip 2.